Hello everyone. Today we'll be discussing DFAs, a deterministic finite automata. A DFA is a finite state machine. Finite state machines are used to describe regular languages. They contain a set of states and can change from one state to another from an input. So DFA. So these are states. States are represented with some type of symbol, with a circle around it. Um, so there are two kinds of finite state machines. The one we'll be discussing in this video is, again, the DFA. The general rule for a DFA is that it cannot be in more than one state at a given time. However, in the future video, we'll see something called an NFA, which can be in several or more than one state at a time. And yeah, it's generally easier to write an NFA than DFA. People usually write an NFA and then convert it to a DFA. Oops, can't spell. So to describe a DFA, we use 5-tuple. So let's say our DFA is DFA n, and contains the 5-tuple. Let's see. First element is Q, representing the set of states. Second element is sigma, representing the alphabet, the set of letters or symbols. Next is a transition function. We'll see more about this later on, lowercase delta. Next is the start state. I'll use A to represent that. This is not a set. This contains one element, well, points to one state. The next and final one is the accepting state. So this is a set of states. Yeah. Let's begin by talking about the elements of our 5-tuples here. Let's scroll down. So let's talk about Q. So Q is, again, our set of states. Q contains the states that are in our DFA. Let's create our DFA. So A, and we have B. So these are our two states of our DFA. States are represented by a symbol, any type of symbol, and a circle around it. So our states are A and B. So as we describe these elements, we'll construct our DFA, and hopefully that'll help you understand a little better what a DFA is and how it looks. Alright, so the next element is sigma, which represents our alphabet. An alphabet, again, a set, and it takes in symbols or letters, and these symbols or letters are what our DFA can understand. Let's make it simple and do zeros and ones. Zeros and ones. So for example, our string can be like this, and our DFA will be able to understand it. If it contains A, B, C, D, it will not be able to understand it because it's not part of sigma. We could, however, add it here, and then it would understand it. So our next element is delta, lowercase delta. This is the transition function. This also takes in a set. We'll skip over this for now because it's a little bit more complicated. I made a mistake here. Let's make this Q sub 0 to match a textbook definition of it. So Q sub 0 is our start state, and this points to one state, not a set of states. Let's make A our start state. So represent start state by pointing the arrow towards this graphical representation of it, or diagram, and that's an A. So that's where we start. this is where we read our input string into. When we read an input string, we move from left to right. So one will be interpreted first, and then the next one, and so on. So our next element is the final states, accepting states. And this takes in a set of states. So we can have more than one accepting state. In this case, to make it simple, let's make B our accepting state, represented by a double circle. We can also make A our accepting state, but to simplify this, let's make B our accepting state. So depending on what this arrow is, or whatever states are in between the start state and the accepting states, that will allow certain substrings or strings to pass to the accepting states, and that string would be accepted, if that makes any sense, by our DFA. An example would be strings that end with 0 and 1. This will pass into our DFA, and depending on how we structure it, it will accept this string. For example, if it accepts ending 0, 1, we will have to structure it in a way that accepts strings that end with 0, 1. That will most likely be our next example, or in this video. So let's begin talking about the transition function here. So transition function basically takes in the state and the input and tells you which state you're going to be changing to. So for example, let's rewrite our DFA over here. So we have A start goes into B. Let's say to get out of state A to B, you need to have a 0 as an input. Our transition function will take in A at 0 equals B. That's basically what it is. If this also accepted a 1, it would be transition function A at 1 equals B. Let's say from B we have a 1. So from B we have a 1. Oops. Oh, no. This is not valid. It doesn't have anywhere to go. And we need to correct that because this DFA becomes invalid without. You need to fill in, you need to tell the input string to go no matter what the input is in a DFA. NFAs doesn't really matter, because you'll see later on. So if we get a 1, what do we want to do? Let's loop. So for every 1 that comes in here, it's just going to keep going and looping into B. So if we take in the input string 1, 0, 1, 0, start from 1, 1 goes here, so 1 is now here. The next input string, 0. Oh, so now we also have to answer for 0. Let's also loop at 0. So 0 is looping here. The next one is 1. 1 will loop here, 0 will loop here. And we're good. It accepts 1, 0, 1, 0 because it made it to the accepting state and to the end of the string. So yeah, it's accepted. So let's say we want to just accept a 1 or a 0. This is a 1 or a 0, which makes no sense. Let's say we want to accept just 1. You would have to say at state A 1 comes into this DFA. We only want 1 to get processed here. So 1 comes in and it gets stuck in this loop because we only care about this first 1. And it keeps looping. So this DFA accepts any string that begins with the number 1. But we have a problem here. State A needs to handle if our input begins with a 0. So what happens with 0, 1, 0, 1, 0? It becomes invalid again. So we can either loop back here to skip that 0, but that leads to a problem. It's going to accept strings that begin with a 0. So we do something called dead state. So C will be our dead state, and at input 0, it goes to the dead state. And then it loops at 0. But we want to disregard the entire string, right? Because it needs to begin with 1. So we can do comma 1. So this entire string will be rejected because it's looping out over here, 0, 1, 0, 1, 1, 0, right here. And this string will go 1, 0, 1, 0, and get accepted. And the transition function, these, you can remove them now. So that's basically what a transition function is, and a little extra. But again, just fill in our transition function. So we have transition function at A, at input 0, we go to C, at A1, we go to B, at B0, we stay at B, at B1, we also stay at B, at C, at 0, we stay at C, because we're looping out, C at 1, we're also staying at C, and we're looping out. Oh, sorry, this is messy. So this is our transition function. And this is a little hard to understand if our DFA is huge, or well larger than this. We can use something called a transition table also. It's a 0, a 1. And we have 3 states, A, B, C. Our start state is represented by this arrow, our end state represented by a star. And we could just look at this. A at 0 equals C. So we go to C. A at 1 goes to B. Goes to B. B at 0 goes to B. Right, we're looping out. B at 1 goes to B. C at 0 goes to C. C at 1 equals C. That's we're looping out there. Yeah, hopefully that makes sense to you. We'll go over another example in the next video. Probably strings that end with a 0, 1. Not sure as yet. If you like this video, please like and subscribe. If you have any questions, leave it in the comment section. Thank you.